All right, chapter 1 still. Now we're going to go on to section 1.3, so simple random sampling. So going to kind of talk about different samples that you could take. So random sample is a process of using chance to select individuals from a population to be included in the sample. So let's pretend that we're all sitting in class and I write everyone's name on a little piece of paper and put it in a hat. Us shaking the hat and randomly pulling different pieces of paper to reveal individual students. So that would be considered random sampling because everyone now has an equally likely chance of being selected. So we could do that. Our class is relatively small. Let's just say that we have like 40 students in the class. So we're able to do that, but let's think of the entire population of Chaffey College, right? So with all of Chaffey College, it's going to be really hard to throw everyone into the sample. So there's other methods that we could use. So the key to obtaining a sample representative of a population to let chance or randomness play the role into dictating whether the individuals are in sample rather than convenience. So if convenience is used to obtain a sample, the results of the survey are meaningless. So convenience does not mean that convenience is not like a justification for our random sample. Convenience would be like me going to the grocery store and asking, do you go to Chaffey College? Do you go to Chaffey College? And kind of grabbing every student that I know that goes to Chaffey College there. That would not be a good justification of the people, or it would not be a good representation of the students of Chaffey College. It's only the students of Chaffey College that went to the grocery store that day. So that's not randomness. That's very, very selective. All right, so a sample size n, little n, from the population size big N is obtained through simple random sampling. So if every possible sample of size n has an equally likely chance of occurring. So the sample is then called a simple random sample. So simple random sampling, every sample size of size n, or every sample of size n is equally likely to occur. So that means that we have our population again. So that means we have our population here. This sample is equally likely to happen or be selected as this sample here. So them overlapping means that there are individuals in here that belong to both this sample here and also this sample over here. All those look like two chocolate chip cookies. But anyway, so we're looking at those as individual samples. So it doesn't have to mean that they're exactly different. Like looking at this sample over here is very different from those samples. There's not one place where they overlap. So those are three completely different random samples. Okay, so each random sample has an equally likely chance of happening. So there's that. So the number of individuals in the sample is always less than a number of individuals in the population. So let's just make sense of that really quick. So we have our entire population. Say there's 100 people here. We can't grab people outside of this population and say that there's like 101 people, because we're grabbing people that are not part of the population. So they're not going to be part of the study at all. So it's always going to be less than whatever the population size is. Okay, Sophia has 4 tickets to a concert. 6 of her friends, Yolanda, Michael, Kevin, Marissa, Annie, and Katie, have all expressed an interest in going to the concert. Sophia decides to randomly select 3 of her friends to attend the concert. A lists all possible samples of size 3 from the population of size 6. Once an individual is chosen, he or she cannot be chosen again. So basically we can't have Yolanda, Yolanda, and Yolanda as one of the sample sizes. It has to be Yolanda and 2 other people. All right, so let's see, do we have room here? All right, so looking at this, we would first have these first 3 here. So that's sample number 1, We could have 1, 2, 3, that's sample number 2. We could have 1, 2, 3, sample number 3, so on and so forth. So they got every single different random sample and they threw it into this list right here. So the very first one is going to be Yolanda with the other people. So Yolanda, Michael, Kevin. Let me just write the names down really quick. So Yolanda, Michael, Kevin, Marissa, Annie, and Katie. So the first one are the first 3. So Kevin, Michael, Kevin, or Yolanda, Michael, Kevin, Yolanda, Michael, Marissa, Yolanda, Michael, Annie, Yolanda, Michael, Katie. So the next one, we can't have Yolanda, Kevin, and Michael because we already have that one right here. So from here, we did all the different possibilities with Yolanda. Now we could do all the different possibilities with, or we did all the possibilities with Yolanda, Michael, and now let's do Yolanda, Kevin. So Yolanda, Kevin, Marissa, Yolanda, Kevin, Annie, and so on and so forth. There ends up being all of these different possibilities here. So 3, 5. So 5, 4, 3. So there's that many different possibilities there. All right, so clear. So from the table, we see that there are 20 different possibilities of sample size 3 from the population of size 6. So the term sample means the individual is in the sample. Yeah, so the term sample means the individuals of the sample. We're not looking at each individual individually. We're looking at just the samples of size 3. All right, part B. So what was the question? So comment on the likelihood of sample containing Michael, Kevin, and Marissa. So Michael, Kevin, and Marissa. So Michael, Kevin, and Marissa. So there's only one time where that's going to happen. Michael, Kevin, Marissa. So there's only one time where that happens, and that's right there. So 1 out of those 20 different possibilities. So one of the 20 possible samples contain Michael, Kevin, and Marissa. So there's only a 1 in 20 chance that the simple random sample will contain these 3. In fact, all samples of size 3 have a 1 in 20 chance of occurring because there's only 1 of each of these individual ways. So that's how we could justify those. And there we go. So now obtaining a simple random sample. So each individual in the population is assigned a unique number between 1 and n. So capital N meaning like the size of the population. So the n distinct random numbers from the list are selected where n represents the size of the sample. So in the case that we just did, we had capital N equaling 5 because there were 5 different people. Little n was 3 because there were a total of 4 tickets and Sophia was definitely going to take one of those tickets. So there was only 3 slots for the other people. So sample size of 3, population size 5. So the number of individuals in the population, we need a frame or a list of the individuals within the population. All right, so in a sample without replacement, an individual who is selected is removed from the population and cannot be chosen again. In a sample with replacement, the selected individual is placed back into the population and could be chosen a second time. So a way that we could think of this is when selecting a pin. So let's say our pin 1, 2, 3, 4. Whenever we use the number 1, let's pretend that we have the number 1 selected here. us using 1 right there does not mean that we cannot use 1 right here too. So this would be with replacement, we're able to replace 1 and throw it back into the running of actually using those numbers. Without replacement would be us like ranking people. So as soon as we rank the different people in this class, we can't reuse them. So one person can be ranked 5th, but also be ranked 20th. So that would be without replacement. All right, so an accounting firm of the Sensies and Associates has grown. So to make their clients, to make sure their clients are still satisfied with the services they are receiving, the company decides to send a survey out to a simple random sample of 5 of its 30 clients. Step 1, the table on the next slide shows a list of clients. Rearrange them in alphabetical order, although this is not necessary, and number them from 0 or from 1 to 30. So we're starting off with 1 and going all the way to 30, and this is the list right here. So ABC Electric, Brazil Constructions, Bridal Zone, all the way up to Worldwide Wireless. So it looks like they already put it in alphabetical order for us. They didn't have to. They could have just went with like whoever signed up with them first. The order here doesn't really matter. What matters is how we select the numbers. Is it random? And we got that part. Step 2, a table of random numbers can be used to select the individuals in the sample. See the table in the next slide. So we pick a starting place on the table by closing our eyes and placing a finger on it. So this method accomplishes the goal of being random. So, or suppose we are starting in column 4, or here, let me just show you. So me closing my eyes and selecting this, well, not that part right there. Get a different color. All right, so me closing my eyes and selecting this spot right here, we would start definitely with this spot, the 1, 2, 3, 4th column going down to the 7th row. So us starting here, that's basically making it random. So closing your eyes, kind of picking a place. But here, what they told us to do is suppose we start column 4, row 13, because our data have 2 digits. We select 2-digit numbers from the table using columns 4 and 5. We select numbers 1 through 30. And instead of reading all this, let me just show you. So we're starting out with column 4, row 13. So we could think of this as column 1, 2, 3, 4. And row 13, they kind of numbered it for us right over here. And we would start with, oh, I'm sorry, not there. So we're starting with this as like, here, let me do it from the bottom. So 1, 2, 3, and 4. So looking at the 4th column, instead of looking at the 4th column up here. All right, starting with this value right here, highlight it. So starting with that 5 right there, and we're looking at 2-digit numbers. Remember, coming back over here, 2-digit numbers, we have 0, 1 here, all the way up to 30. So the smallest digit is going to be 1 digit, but the largest digit is going to be 2, or the largest number we have is 2 digits. So we're going to run with 2 digits. All right, going back, we start off with this first value here. And instead of just looking at that one individual number, what we're going to do is look at the, and it should have been 13 right there. We're looking at that entire 2 values of numbers. Can I zoom in? And I guess we can't zoom in. All right, so we would see this value right here. And the very first value that we're going to see is, or that we're going to use is 1. So 0, 1. And we needed a sample size of, where was the sample size? Sample size of 5. So we're going to pick the first 5 values that we see. All right, so 0, 1. The next one is 52. So 52 right here. Then the next one is going to be 07. Then the next one is 44. Then 46. And that should be 5 numbers. Okay, so we're looking at numbers between 1 and 30. So 1, that's definitely a value that we could use. 52, we don't have 52 clients, so we can't use this number here. 07, we could use 7 because we do have at least 7 clients. We have 30 clients, so we can't use this value either, or this value here. So let's go back to our table over here and see what the next value is. So that was 46, the last one we had. Next is 37. We can't use that one either. 26. We could use that one. So far we have 1, 2, 3. And we have 26, 11. We could definitely use that. Now we have 4. And now that we use this one, we're going to come right back up here and just kind of follow the columns. So here the next one is going to be 23. And 23, we do have at least 23 here. And do we have any repeating numbers? So 1, don't have any other 1s. 7, we don't have any other 7s. Next one we could use is 26, don't have any other 26s, don't have any other 11s, and 23 is by itself as well. So that's going to be our list right there. So our list of clients is going to be the client representing 1, the client representing 7, the client representing 26, and the client representing 11 and 23. So those are our 5 different individuals. All right, and those are the exact same numbers that we came up with right there. So we display each of the random numbers as selected. So let's go back and see what companies they are. So we have company number 1, so ABC Electric. Company number 7, Dino Jump. Company 26, Travel Zone. 11, Fox Studios, and 23, Simplex Forms. So those are the 5 companies that we're going to contact to see if they're satisfied, if they're still satisfied with the 5 companies to see if they're still satisfied with the service that they're receiving from the accounting firm. And there we go. That's how they got those values right there. All right, next, find a simple random sample of 5 clients from the problem presented in the previous slide. So 1, the first table from the previous slide example shows the list of the clients and the numbers corresponding to the clients. 2, figure A on the next slide shows the seed set, an initial point for the generator creating random numbers at 34 on ATI 84 plus graphing calculator. We could skip this. So another way of finding random samples is we could go online to random number generator or random.org. That's another really good one. So here you could put your minimum. In our case, our minimum was 1. Our maximum was 30. And we hit generate. And it generated this value here for us. So 2, 6, 28, 1. So you keep clicking it until you have your desired amount. Sometimes it does repeat numbers, like I do believe that we had 6 earlier. So we would just have to redo that number. So hit generate again, and it would generate a different number for us. So this one is an organization that actually came up with generating random numbers. So it's not, there isn't any sort of like value that's gonna keep popping up or anything. It's all random. And there we go. That was 1.3. So if you guys have any questions, just send me an email. Good luck.